What is an oscilloscope trigger? Why do we need it? And how do we use it? We've got the answers to these questions coming up. At its most basic, an oscilloscope is a visualization tool. You can think about it the same way you think about a camera. Like a camera, an oscilloscope captures signals, which it displays as images that we see and interpret. When you take a picture, you check it to see if it is in focus or out of focus and whether it represents what actually happened. When we talk about these things in relation to an oscilloscope, we talk about signal fidelity. But before you think about any of those things, you first have to capture the image. This has been pretty easy on a camera since Kodak introduced a simple button that paved the way for modern photography back in the late 1800s. But imagine there was no button. Imagine you had no control over when the image was captured, and you just had to point it at the subject or object and hope it was captured at the right time. And to make this thought experiment even more fun, imagine your subject was a race car moving quickly around a track. The result would be pretty much the same as you'd get from an oscilloscope without a trigger. The oscilloscope would acquire data in a random way that isn't very useful for getting a clear picture or meaningful measurement. And, after all, the real power of an oscilloscope is that it's not just a signal visualization tool, but also a measurement tool. So this is why we use a trigger. A trigger system lets you specify the portion of your signal to capture based on the conditions you set. It could be a repeating signal or a single event. It basically synchronizes your scope with the signal. A trigger makes repetitive waveforms appear static on the oscilloscope by instructing the oscilloscope to start the scan at the same point on each repetition of the waveform. The result is a stable image that you can measure. And, no surprise, the more skilled you are at triggering the oscilloscope, the better and easier it is to get insightful measurements. Luckily, today's modern oscilloscopes come with advanced trigger systems that are easy to use. You'll find the trigger button conveniently located on the front panel of our scopes. Most oscilloscopes operate the trigger position from the horizontal control section of the oscilloscope menu. Everything to the left of the trigger is pre-trigger data, while data to the right is post-trigger data. Being able to see pre-trigger data can be very useful. If you're triggering on a problem, looking at what the signal was doing before the scope triggered can help you understand the cause of the problem. The basic and most common type of triggering is called edge triggering. With edge triggering, the waveform is captured when the signal on the trigger source passes through a specific level on the rising or falling edge of the trigger source. We set the trigger point to a particular value, which results in the scan stopping at the point where the trigger conditions are met. Then, the waveform is displayed on the screen. While an edge trigger is the most commonly used trigger, there are many circumstances when this will cause too many triggers to occur, resulting in unstable waveforms. To help the engineer, there are specialized trigger settings that can save hours of measurement time. These triggers respond to specific conditions in the incoming signal, making it easy to detect, for example, a pulse that is narrower than it should be. You can trigger on pulses defined by amplitude, qualified by time, and delineated by logic state or pattern. If you look at the trigger menu, you'll see that the oscilloscope does not necessarily need to trigger on the signal being displayed. You can also use other sources to trigger an acquisition, including any input channel, an external source other than the signal applied to an input channel, the power source signal, a signal internally defined by the oscilloscope from one or more input channels. Most of the time, you can leave the oscilloscope set to trigger on the channel displayed. When you are choosing a trigger source, you want to avoid using a noisy signal. Often, when making measurements on signals, there is a layer of noise superimposed on the signal. This noise can make it difficult to get the oscilloscope to trigger in the same place every time. It's the same as trying to hear someone talk in a noisy room. You won't be able to hear them as clearly as you would if the room were silent. Luckily, modern scopes have several filters to reduce noise and make the engineer's measurement job easier. Thanks for watching. If you liked this video, hit the subscribe button now to get notified of our next video in this educational series. For more information about oscilloscopes, download our Fundamentals of Oscilloscopes guide at the link below.